So I am pleased to introduce our speaker today, Daniela Paz-Erez, who is the founder and CEO of the Paz Group and Urban Dashboard. And she will be talking today about the use and integration of innovation to optimize urban design. Daniela Paz-Erez is an expert in urban planning and real estate economics. She is the founder and CEO of Paz Group, which is Israel's leading real estate consultancy firm, and that was rated by Dunn's 100 2021 as the leading real estate consultancy firm in Israel. She serves as an advisor to all major Israeli banks, as well as leading construction firms. And she regularly consults Israeli government ministries, municipalities, and other authorities in urban planning policies, zoning, and more. She is a certified economist and appraiser. She holds an MBA from Tel Aviv University, and she also lectures in various academic and professional forums. So with that, Daniela, I would love for you to start. Thank you.
Thank you, Jackie, for the warm words. I will share screen now. Okay, so hello everyone. I'm Daniela. 25 years ago, I founded Paz Group, which, as Jackie said, the leading Israeli consultancy firm in real estate. And for the last decade, Israel is been under a severe housing crisis, and it urged the urban planners to find housing solutions. And Paz Group, as a firm that deals also with planning, we also are managing thousands of units. We plan them, and we are also dealing with the process of infrastructure, the economic aspect. And all of that is done by traditional human-based planning methods. And we sought and looked for technology to help us and others in the process of planning. And that urged me and a group of great people to found Urban Dashboard 2 years ago. And that's what I'm going to present to you today. So, Urban Dashboard. It is a decision support platform for smarter, faster, and more efficient urban planning. Our mission is to empower planners and collaborate with a platform that can help analyze in a very early stage of planning. The platform currently is in an advanced developed stage, and we will talk about what it can do and how. But first, let's talk about the process of urban planning. The proficiency of urban planning is very complicated. The stakeholders are different with different interests. The developers, the state, the municipality, the public, each and every one of them has different needs, and maxima, or the stakeholder maximizes benefits in a different from a different aspect, and the planner or the policy maker that need to approve the plan need to coordinate with all these interests and address to everyone and align the interests, and the amount of data and the amount of aspects that are dealt are huge. And it is going to get much more complicated. The future of planning cities is that we are looking is going to be different in a lot of aspects, like future mobility that changes the way that we drive and commute. We can look at the future of autonomous cars, electronic and the challenges of changing the roads because of that. And also the workforce of the future, looking at the mixed use that needed because people work from home and they need different facilities near their house. And of course, the housing crisis that increasing all around the world, and the need to agile the zoning, and all of that creating a huge need or is challenging the planners and the urban the people that deal in this stage of urban planning. And we cannot think that we can plan the future cities with all tools. And the thing that we saw is that in this specific stage of urban planning, the lack of technology and economical tools is very different from the other stages of the process of real estate. We see GIS, geographic information system, in the land or layers of data. When we construct or detailed design, we see BIM, building information modeling, and we see smart cities when it comes to managed city or even building. But the urban planning stage, lack of technological tools, we see 2D CAD as the common tool to plan. And here I want to show you how important it is to use tools or to know the effect of the urban planning in early stage. Here you can see the blue line that shows the ability to affect at early stage compared to the late stage or the operation stage. You can see that the ability to make changes at the end of the process is almost zero. And at the beginning, we can change almost everything we want. And the cost is almost nothing. If you want to change the location of a road in the beginning of the process, it means to draft another version by the architect. But if you want to do it after the road was paved, it will cost you demolishing the road and paving another one. And if we see the CAD tools that were used 20 years ago, these tools, the technological tools, dealt with the construction and the detailed planning and helped the architects and planners in that stage. In the last few years, we see BIM, building information modeling, 3D models that help the detailed design and the preliminary design stage. And now we want to offer solution for the early stage, the urban planning stage, when you do only the zoning. So now I want to talk about the cost of urban planning bad decisions or not knowing the outcomes at the beginning. With two examples. The first one is in Harish, Israel. It is a major new urban center in over 100,000 people, population very large, and need a new road. The planners decided to pave a road 50-meter wide on a hilly region, side in a mountain, on the mountain, and the cut and cover of, or the cut and fill of the road costs a lot. It doubled the levies or the infrastructure cost in this area. We tried to find a different solution by using our tool Urban Dashboard, and we found that for sure using Urban Dashboard in an early stage would have saved a lot by changing the location of the road, different a solution for transportation, like splitting it. And this is just one example of knowing that at the beginning probably would have changed the way that the planners decided to give the solution for the problem of transportation. Another example is in Kiryat Gat, Israel. It's a city in the south that a new neighborhood of 7,000 units was planned, and the layout was high-rise alongside townhouses. This is a neighborhood that was supposed to give solution as an affordable housing for 7,000 families in Israel. And the government or the planning authorities in Israel asked us to try and find out a different way of layout in this neighborhood in order to see if they could save money by changing the buildings that are planned, that were planned. So we did examination, and we found out that changing the plan to low-rise, not high-rise, not townhouses, low-rise building with the same amount on the same land with almost the same quality of life could have saved 20% of the cost of each apartment. It is $50,000 that could have been saved if the plan was planned differently. So these two examples, just to show you the importance of using a tool in the preliminary stage, and that led us, like I said, to find technological solution. And I want to present Urban Dashboard. It is a decision support system for urban planning that help to do a multivariate analysis for urban planners, decision makers at a very early stage, and see the analysis of a variety of aspects like economic mobility, environment, and others. And I will share a short movie that to emphasize how it works. Oh, stop. Okay, so we want to transform the way cities are planned, And the core features of urban planning, urban dashboard. The first one is the site analysis. We provide a lot of data layers in each geography that urban dashboard can work on, and the user can do a very quick site analysis and find out a lot of regulations and restrictions that are relevant to the plan that is looking at. And then it can plan on the, like you see, the urban dashboard allow you to plan on the platform and also to import your plan and then explore it and optimize it and try to analyze it in a lot of aspects. And then you can see the results for each and every scenario and compare the alternatives and also present your plan or your alternatives to the decision makers or to others that are interested in the results in early stage. And urban dashboard is can be used both for developers, urban planners, consultants, managers of projects, and also academy and students. The analysis that we are providing in 4 core aspects: economic, mobility, sustainability, and infrastructure. The economic indicators are the construction cost, the cost of parking, and the value of the tradable areas, program for the public needs, and so on. And the mobility indicators show the space index grid network and other aspects of transportation, like a street section with the street users. The environment indicators are dealing with the solar rights, shading, radiation, wind, walkability, and other. And the infrastructure development, we are looking at the earthwork, the slope, the type of soil, and also drainage and road paving cost. I will talk about it in my examples in a minute. So in order to understand the power of this tool, I want to show you a few case studies. And the first one is the use of urban dashboard by a group of planners that are working on a metropolitan metro system above ground plan in Israel. In Israel, we don't have metro. We are just planning it right now. 3 lines and 109 stations that are gonna cover 150 kilometers. And above ground area that is affected from the metro, the immediate area that is affected is 200 square kilometers. It is a huge plan, 40% of the commercial corridor of Israel. And Urban Dashboard was the platform that they planned or did all the examinations in order to plan the above ground area. I will show you one aspect that we did. What you see here is an example of 7 metro stations that are within one line, that are a cluster. And first, Urban Dashboard created a layer of all the parcels. That's what you see below. And then we imported the station centers and the entries of each and every station. And then we marked radius of 300, 600, and 800 square meters, and 150 meters radius from each station entrance. And then we got we run a algorithm that created the influence area polygons surrounding each and every station by a set of guidelines and constraints regarding the lots and the building surrounding each station. This was done for all the 109 stations. And I believe that people that needed to do it by hand, it would have taken them much more time. It is automatic, and if you change the construction, the algorithm change the area in a minute. So that was very helpful for the team that planned the above ground. And this is only one example of what they did, but the work of the team was in a lot of aspects, and Urban Dashboard was very useful for them. And I think that without a platform, a technological tool, it was very difficult to deal with a huge amount of data that needed to be dealt in plan like that. And the complexity was very, it was something that we helped a lot with Urban Dashboard. The result was generating the area surrounding of each of the 109 areas according to all the local constraints and the needs of each and every municipality, and we are proud of that. Another example deals with the water management. A new neighborhood was planned in a city called Or Akiva in Israel. As you can see, a river runs along the development side, which make it flood prone. The planning team proposed a solution of raising the entire neighborhood by 3 meters, and that to avoid the future floods. And we ran an Urban Dashboard model to check whether there's another solution that doesn't need to raise the whole neighborhood. And we did that and found that, yes, we can. And the alternative we found is that you can spread the buildings and use the area, the green area in the middle to absorb the water in case of flooding. And by the way, it saves 10 million shekels or $10 million to the company that needed to build this, to do the infrastructure. Here I can show you the model of what we did. You can see the river and the topography, the flood area, and then after the model ran, we knew how to change the building in a way that the area in the middle can absorb the water. Okay. Another important case study was made for ARIM. ARIM is a government real estate infrastructure development company in Israel. And the goal was to place the marketable lots in the most cost-effective way, taking into consideration the existing roads and the topography. And what you see here is that Urban Dashboard enable us to decide which is the most effective path, taking into consideration the cut and fill cost. What you see here is the road in this side shown here, and here you can see the cut and the fill needed and the percentage, and also we calculate the cost. And here you can see a demo of the building position by the solution that Urban Dashboard gave for each alternative. So this is another example. Another core feature of Urban Dashboard, a very cool core feature, is the building volume engine. Once the user fills a few relevant parameters, Urban Dashboard is able to generate building volume according to the typology of the land. The building volume engine generates and optimizes the 3D model, as you see, according to each specific lot attributes. And the result is a very efficient design in near real-time experience and a minimum user input. Once you have your 3D model, you can use it to do a lot of analysis in instant, like this analysis, the environmental analysis of shade and the envelope that the shade is creating on the surrounding. So in this demo, you can see the shadow analysis result. Basically, there are three levels of shadowing effect. The green one is the best alternative, and the yellow means you can live, but not perfect. But and the red is the area is you need to address it by new planning or change the building nearby. And also you can review it and use this when you present the plan to the authorities. And this is the last case study that I will show you. It showed the pedestrian walkability analysis. Urban Dashboard was able to model the distance that can be covered in 5, 10, 15, and 20 minutes at a normal walking pace. And in this example, you can see the algorithm that we created and the influence polygon surrounding the planned. Here it's also a metro station, and according to the walkability logic, you can see the areas that are served in this distance time. Okay, we're getting to the end. To summarize, Urban Dashboard is a smart, chic, very useful platform for urban planning. We're working on a very slick design of user interface, and we will probably release our beta in a few months from now, very soon. And it is for commercial use, but we really would like students to use Urban Dashboard as a platform for research and use it to analyze existing or planned areas. So that's why we are very happy for the introduction, and we are ready to hear your and see your analysis on Urban Dashboard as well. Of course, we invite anyone to contact us. We will leave the numbers also in the chat, so you can contact us. So I wanted you to ask us as much questions as you want. I see we have only one in our chat, but feel free to ask everything that in your mind regarding what I showed you. I want to present Ziv Livnat, a co-founder in Urban Dashboard. He's very experienced. He has more than 13 years in business development and product experience, and as a co-founder the last 2 years in Urban Dashboard, is in charge of the product and the design of our analysis, and he will love to hear you and ask and answer your questions. And we also asked Liat Halperin from Urban Dashboard to join us. Liat is in charge on the, she is coordinating the work with NYU, and she has a vast research and operation experience. Liat studied in New York, and she holds a master in urban affairs from Queens College, and also a degree of urban planning and policy from Connie Graduate Center. So there is one question, Ziv, you want to answer?
Yeah. First of all, again, thank you for allowing us the time and for the question, and a very relevant one regarding data. So we have global data sets, but the richest data sets that we have are in Israel, of course, and in the Dan metropolitan. But we already covered a few metropolitan, and we are expanding on a metropolitan base. And based on request, we don't mind moving different milestones for the data sets and focus on different regions. So it depends on the maturity of the data within a region. But if you have a specific region, I will be more than happy, if I know now, to answer, and if not, to check and to get back to you. But we are trying to establish it on a metropolitan base, so not everywhere, but on the main metropolitans. Hope it answered the question.
Yeah.
Wonderful. Yeah, if anyone else has any questions, please feel free to just start speaking or raise your hand, or just, oh, Charalampos has a question. Charalampos, do you want to go ahead?
Hi, thank you for the very informative presentation. One question also for the students in this call is, what kind of algorithms do you use in the background? For example, you mentioned how there are tools to find cost of urban design decision making, and you use optimization with the low rises versus high rises. So is there an optimization problem on the background that you run given the inputs? And if so, what is that?
It's a very good question to present a very complicated issue, but we have recognized it through design partner, and this is why we are focusing on it. We're not expecting to work on it, and it's not that mainstream, but apparently it's a very influential aspect when you reach a greenfield or a new project with outside of a current urban scope. And once you need to define the roads when the different parcels that are adjacent to it, any movement within the cut and fill of the parcels actually create quite a lot of difference for future mobility, either walkability slopes or driving slopes, and drainage, of course, and also influencing if you want to keep the current terrain and as less interaction as possible, or you would like to create the best environment for future development. Each one of them is actually quite drastically influencing each unit cost and levies to implement it. And it's actually a little bit of hidden giants within the urban realm. And we defined it as a very interesting one and actually a very optimized task, oriented task, which is not always in the urban realm. So we are very much interested in it and we're researching a lot. There is quite a lot of algorithm that we are writing in order to tackle it, but we could not find an open source or too many research. There is a lot of research from the, of course, from the engineering side, but less on answering it from both landscape issues to architectural issues to developers' requests to minimize the cost for implementation, but also optimize the ability to create the most optimized road system and slope for movement and for keeping the environment. The less trees we are cutting, the better the environment will be. So actually it's involved quite a lot of optimization algorithms, and it's a quite fascinating topic with heavy levies involved. Hope I answered the question.
I can add regarding high-rise compared to low-rise cost. In PAS Group, the consultancy firm, we analyze the cost of construction, and we can divide it to the different needs in each type of building. And we did it in a way that you can make it automatic. You can do the algorithm to see the connection between the kind of the type of building and the cost. And when it's high rise, usually you need much more areas for plumbing, and the cost of construction is usually a little bit higher. And then you have to, for the parking, the underground parking, you have to dig deeper, and all of that was calculated. And we found that you build more square meters because of the common areas. For the same area of apartment, and that's why there is an optimal building that costs minimum and give you almost the same result. But then you need the computer or the algorithm to find if you can allocate all these buildings or all these apartments on the same area without damaging the green areas and all other needs. And that's what we did, and it was amazing to see that you can do it and save in that 20% of the cost.
Thank you. Seems like there is lots of computational work also happening in the background. Thank you.
Yeah, sure.
It's true.
Yeah. What we will be very happy to see if students that are doing research with cities like New York or others, and tackling problems like we showed you or others that computer can solve, can use the platform and do it automatically, and then of course offer the same this analysis to others. That's what we are doing in Israel, and we want to duplicate it to other places.
I have a question that this is very fascinating. First of all, thank you so much for the talk. I really loved it, and I love how you were showing so many case studies, so many concrete examples of your work and how it's being actually used for solutions to real problems. So that's wonderful. And I was just curious that towards the end, you presented a case study on flooding. So it was like before the city is built, you would decide on the building locations, the optimal building locations, and then having like kind of a, I guess what I wasn't sure, but it was just that you would dig kind of like a slight hole in the center so that like the water would go there, right? Is that correct?
We didn't dig, we just opened the area so flood can be absorbed in the green area. You don't need to dig, you just let it.
Okay, so it's like just because it's a green area, then it'll like kind of be compressible a little bit, and so then the weight of the water will kind of create like a natural reservoir there. Okay, and then I was curious, like does it have to be in the center, or can it, like, let's say for instance, you already have a city and you already have buildings, and then there's some open spaces here and there. Can you just, after the city is already built, create I guess just having more green areas would help with flooding, because then like you would allow it. So I'm just wondering, like, if your tools can be used to help with like a city that's already built, putting in more green areas or other structures to help with mitigating flooding.
Excellent questions, and it was a fascinating project. We worked closely with an eco-hydrology to define some of the solutions and to see how best mitigate it with preserving the green areas. So when you approach already a current urban fabric, there are quite a lot of interdependencies as what was preserved and what type of green area it is. Is it an intensive park, which was the past topography and the ecosystem has been changed, or is it some kind of a forest or an open area that was preserved in the past? I'm asking it because the drainage decision made by engineers in the past and road infrastructure is the one to decide the movement of water once the area was interrupted. So if the natural slopes remained, there is quite a lot of job to do. If the slopes have been modified and engineer decided about the tunneling or the pipes to resolve the drainage and the influence over different floods, then it's quite a complicated model. We can run it on a city scale, is actually make it much more interesting, because the problem usually is that you don't do it in a city or a metropolitan region, but more locally, and then you are losing the bigger picture or the bigger ability to create new solutions. But I think it's also a very global issue, as cities are evolving and becoming more dense, and you see more floods. We think it will be a very interesting development to offer cities new solutions to better green area and better drainage. So we're up to it.
Thank you.
I think that if you don't have a question now and you will remember that you want to ask something later, I think after maybe write the number in the chat so they can copy.
Sure, I will write here the number and also our email. You can also look us up on LinkedIn. We're always available, and we have people in the US, in the UK, so we're available on different time zones. So feel free to reach out to us, and we're happy to hear from you, hear about what you do, maybe your studios or other courses that you have that you think maybe Urban Dashboard could be useful for you. So please don't hesitate to reach out to me or to anyone from Urban Dashboard.
Wonderful. Thank you so much. So are you going to put that information in the chat?
Yes. I'm doing it right now.
Well, I just want to thank our speakers again. Thank you so much. That was really a fascinating talk. We really, really enjoyed it.
Thank you for having us.
Oh, and we have Juan Bello here. Dr. Bello is the director of COST. He's joining in. It says Kimberly Reed on his, but that's Dr. Bello there.
Oh, I just realized that. But good to see you both again. And Liat is also in the call. So yeah, good to see you all. Thank you for the talk.
Thank you.
Thank you very much for the opportunity.
Okay, so you have our details here. We'll be happy to hear from you, and you are more than welcome to ask us whatever you feel that you want to know more.
Oh, Charalampos has his hand raised again. Charalampos, do you have another question you want to ask?
I have one more question before you leave. I was wondering about a second feature. So you shared how the dashboard in the land use plan according to local needs project. So I was wondering if you could elaborate what kind of local priorities the dashboard accounts for already, and maybe if you have any plans, if that is sort of automated in the dashboard, and if there are any plans to add other local priorities, because I know equity, for example, designing infrastructure such that different populations have access to all services is a concern for many also in New York City.
Excellent questions again. A very interesting one, and we were fortunate enough to work on it from Israel perspective on the metro plan. And they were trying to achieve some of it, not all of it. And we were trying to facilitate different analysis almost in real time. And one of their main issue was to better understand the current environment regarding the different green area indexes and percentage of road to marketable lots within the area, and the difference of density today and in the future for different scenarios. And one of the more interesting scenarios for such a vast plan was in implementation stage and ability for the area to implement what is planned, and the heavier density of FAR which was given to that region, because you can give quite a lot of property rights and capabilities to implement and modify the region in the future. But if the current status do not allow for that prosperity, it will take too long in order for it to mature and implement. So some of the analysis was based on the delta between the current the current stage to what is offered and the expected development. So we made quite a lot of analysis about the different scenarios. We made mostly 3 scenarios: the nominal, what is expected, what is given, what is the current status, and what we expect to achieve in 20 years from the approval of the plan. And based on that, different analysis of mobility, service of mobility, a new large plan in that region, implementation of new large plan in the region, which is also quite influential. But I think one of the more interesting aspects that we are looking at is the modification of mobility, and servicing different type of mobility platforms within the region. Because in some of the stations that we looked at, and we gave the opportunity for the metro to look at, we saw 40% of the land, which is one of the most valuable lands in Israel. 40% of it was covered by roads, but what will be in 20 years from now? And even if you implement metro and different type of mass transportation. So it's actually also presenting an opportunity in the future for both green area and different implementation for that 40% of the land. So it's a combination of all. This is what we were asked to, and this is what we mostly implemented, most of the feature that we implemented, but we are working on different ones. And actually, I think the venue that I think the opportunity working with you is a major opportunity to develop further features, more accurate feature, both to the US, but of course it will be also implemented, hopefully implemented also in Israel and other locations, to better read and to better futurize urban environment and urban movements.
Well, thank you. That was fascinating. And I guess we will end it there. And again, Liat has put in the chat the telephone number, email, and website to their organization. And as she said before, that she's welcoming all of us to reach out and collaborate with their tools that they've built. So this sounds fascinating. I'm sure that there's a lot of students here who could really benefit from these tools in their urban planning research. So thank you so much. We really enjoyed the talk. Thank you.
Thank you.
Bye.
Thanks, everyone.